Hello, welcome back. So let's configure or let's turn on the LED using the registers we've created. I'll come over here and create the main function. Int main over here takes no argument, and I'm going to list our tasks here. First of all, we go into number 1, enable clock access to GPIO. Once we've done that, we go into number 2, set PA5 as output pin. Sorry about that. Okay, and then inside our infinite loop, we're going to turn on the LED or set PA5 high. Okay, so let's start with the first task, clock access to GPIO. We said we're going to do that using the RCC AHB1 enable register. So I'm going to copy this and I'll come over here and then I'll say this equals, we created a symbolic name for GPIO enable. I'll copy this and then I'll paste this over here. But there's a problem here. What's the problem? Let me explain. So I'm going to copy our 32-bit over here. Right. I'm using this as a blackboard, very efficient. Okay, let's say this is our RCC register. This is the content of our RCC register. Just giving an example here. Okay, so this is the initial content of our RCC register, RCC enable, I should say. RCC AHB ENR. So let's say this is the initial content. Now we are saying we want to write GPIO EN. GPIO EN is this. So what would happen is when we just say RCC register equals this, this is what we end up having. This becomes the state of the RCC register. But this is a problem. Why is this a problem? It could be that these bits here are enabled for other part of the system. A different part of our firmware needs this to be high to work. So when we come and we simply apply our equal sign, it's going to clean everything and just write this new value where everything is 0 apart from bit number 0. We do not want that. To prevent this, what we do is we do the OR operator. We simply put a vertical line here. And what this means is that no other bit will be changed apart from bit number 1. So this would simply set apart from bit number 0, sorry, because this is set 0, yeah, apart from bit number 0. So this will just set bit number 0 to 1 and everything else will remain the same. This is known as friendly programming. So we achieve that with this vertical line. And the other part of that is if we want to keep everything the same and set only our particular bit to 0, we use this formation. Okay, we'll see that. So we set GPIO we set PA5 GPIO pin 5 as output. We start off by getting the register, mode register, GPIO mode, and we apply the same method. We say the OR operator over here equals, we first going to set bit 10 to 1. I'm going to copy our code over here, and then remember we saw that Moda 5 occupies bit 10 and 11. The first bit has to be 1, the second bit has to be 0. So we're going to set bit 11 to 0 as well. And I'm going to copy what we have over here. like this. So the same way that this operator ensures just bit 10 is set to 1, combining it like this ensures just bit 10 is set to 1. Combining this operator with 11 here ensures just bit 11 is set to 0. Okay, once that is done, we set PA5 high, and we do this by writing 1 in the position of pin 5 in the modal register, in the output data register, sorry. So I'll copy this, and we're going to use friendly programming again by setting LED pin over here, because LED pin is pin 5 to 1. Okay, right, voila, this is all we have. Now let's build and see what we have. Control S to save. I'll click here to build. It's building. It's built successfully. No error, no warning. I'll run by clicking over here. It's taking a while. I'm going to say OK. And it's going to download onto my board. It's still downloading. Okay, and as you can see, my LED is on. Very simple, very straightforward. It took a lot of time, but it's quite simple. Now, how about we make the LED toggle? How about we make it go on and off? I'm going to come over here and say, number 4, this is the second experiment. Toggle PA5. Okay, so I'm going to first copy this and then bring it here and then comment this. And then this operator, I'm going to change it to the toggle operator. The toggle operator, you press shift on your keyboard and press number 6. You get the sign. Okay, and what does toggle mean? We are in a loop. We run from top to bottom of the loop. When it runs the first time, it's going to be on. The second time is going to be off. The third time is going to be on, off, on, off, on, off. That's what this means. So it's going to be setting the pin on and off, on and off. And we achieve setting it to 1 to 0. On and off means 1, 0, 1, 0, using the toggle operator here. But it's going to happen so quickly that we wouldn't see. Because of that, I'm going to put a bit of delay here using a for loop. I'll say for int I equals 0, I is less than perhaps 1 million. So we're simply going to say, okay, when you turn it on, count to, let's say, maybe 100k, 100,000. So turn it on, count from 1 to 100,000, turn it off, count from 1 to 100,000, turn it on. And this will slow it down a bit so that we can see I++ over here. Let's build and see. I'll click over here to build. It's built successfully. I'll click here to run. It's downloading onto the board. It's still downloading. And there we go. You can see the LED blinking. Okay, so this is it. Over here in this lesson, we have created truly from scratch. Created the addresses, and then created the registers from the addresses, and then created the symbolic names to toggle the particular bits within the registers we want. So this is it. I hope you are having fun. If you have any questions, leave them in the questions and answers area. And do take some time off to leave a review. I'll see you later. Have a nice day.